With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Start the question. So the question says, examine the structural formulas of the following compounds and identify how many compounds are more basic than aniline. How many compounds are more basic than aniline? And so let us first see how nitrogenous compounds are basic in nature. So if some compound is present which contains nitrogen like this, so this is amine, let it be. So this nitrogen is trivalent and this has a lone pair of electrons. So based on this lone pair of electrons, it can give it to a Lewis acid. Thus this amine becomes Lewis base. This is a Lewis base. Now as it is a Lewis base, we can compare the basic strength on the basis of availability of lone pair. So we can say that basic strength is directly proportional to availability of lone pair or electron density. Availability of lone pair, or we can say electron density. And this electron density is further proportional to plus I plus H or plus M groups, which are electron donating groups, and is inversely proportional to minus I minus H and minus M groups, which are electron withdrawing groups. These are electron withdrawing groups. So now let us look at the compounds. So first let us know the structure of aniline. So this lone pair of nitrogen is in conjugation with the phenyl ring like this. So these pi bonds can circulate inside the phenyl ring and we can have another resonating structure like this. So this is NH2 plus, and here we have the pi bonds, and here we have a negative charge. Now this negative charge can come over here and this bond can shift over here, so that we'll get another resonating structure like this. So this one is here, this one is here, and here we get this NH2. So as we can see, the lone pair of electrons is delocalized over here. So based on this, we have to compare the basic strengths. So in the first compound, this is an amide. Now in aniline, in case of aniline, we have this phenyl ring or benzene ring that shares the electron density of nitrogen with itself. But here this carbonyl is present, which is a strongly electron withdrawing group. So what this can do is, it can pull the electron density of nitrogen towards itself, so that nitrogen becomes less basic, even less basic than aniline. So here what happens is, this resonating structure we can get. So here this is NH2 plus and this is O minus, and this C double bond O is a very strongly electron withdrawing group. So this is a electron withdrawing group. Due to this electron withdrawing group, we get less electron density on nitrogen atom. As we can see a positive charge on nitrogen, NH2. So this is less basic. Now let us look at the next compound. Now again, this NO2 is also a very strong electron withdrawing group, and after some resonating structures will arrive at this resonating structure where we have a negative charge over here. So here we have this negative charge, it is double bond NH2 plus. Here we have the pi bonds like this, and here we have this negative charge, and here we have N. This is the structure of NO2 group. This is NO minus and this is N plus. So here also this negative charge can be stabilized by the electron withdrawing effect of NO2 group. So as we can see, the electron density on nitrogen atom is decreasing because of the sharing of electron pair. So this is also less basic. less basic, and the first compound was also less basic because of this NO2 being a strong electron withdrawing group. Now, so here as we can see, this nitrogen lone pair is localized. It is not being shared with any other group. So this N lone pair is localized, and further we have the plus I effect of these groups. This is N propyl group. So we have the plus I effect of this group, and the nitrogen lone pair density or electron density is enhanced. So this is an electron donating group, and we see the basicity of this compound is more. So this is more basic as compared to aniline. Now let us look at the next compound, and this one is a guanidine type of structure. Now linked to this carbon through single bonds, both of these nitrogen atoms can donate their electron densities to this group, so that this will attain a resonating structure like this: H2N double bond C, and here we have this NH minus, and here we have this NH2. So this nitrogen contains this positive charge. So here as we can see, this nitrogen is having a negative charge on itself. That means due to the strong electron donating effect of this nitrogen that is linked to the carbon through single bond, this nitrogen becomes very much basic, because this has a negative charge on itself in one of the resonating structures. Similarly, due to the other nitrogen also, it can also attain a structure like this, that is H2N single bond NH minus, and here we have NH2 plus. So this is also one of the resonating structures. So here also we have this negative charge on nitrogen atom. So this is also more basic because of these two electron donating groups. So these two are electron donating groups, EDG. In the next compound, if we see, here also we have a similar type of compound, but one of the substituents is methyl. Now here also this nitrogen can donate its electron pair, and this can attain a negative charge. So we get a resonating structure like this. So here we have NH minus, and here we see NH2 plus. So this is also more basic than aniline because this contains a negative charge. So this is also more basic. Now in the next compound, that is in this compound, this chlorine has its electron withdrawing effect because this is a minus I group. So being a minus I group, if nitrogen lone pair is shared with this ring, then this pi bond shifts here, and we can see a resonating structure like this. And here we see NH2 plus. Here we have these two pi bonds, and here we see this Cl atom, and here we have the negative charge. Now this negative charge is stabilized by this chlorine atom due to its electron withdrawing effect, and that is why the electron density on nitrogen decreases. So this is electron withdrawing group, and this is less basic. Now let us look at the next compound, and here we have OCH3 attached in the para position. So now this nitrogen can share its electron pair, but this oxygen that is linked to the phenyl ring can also share its electron pair with the ring, which further increases the electron density on nitrogen atom, so that we'll get another structure like this. So here we see that this is OCH3 plus, and these are the pi bonds, and here we have this NH2. This has its lone pair of electrons like this, and here we have a negative charge. So as we can see, in this region the electron density is increasing because of this electron donating group. So this CH3O is an electron donating group. That is why this is more basic. More basic. And the next compound, that is cyclohexylamine, that is also more basic because this does not share its electron density with any other group. So this is more basic. And if we look at the last compound, then this is having an aldehyde group attached to it. And if we see in the resonating structures, this can share its electron density with this aldehyde group, so that we'll get another structure like this. So here we see this NH2 is having a positive charge. These are the pi bonds located over here, and here we see this oxygen having the negative charge. And this CHO group is a strongly electron withdrawing group. Thus, this decreases the electron density on nitrogen, and hence this is less basic. So, at the end, if we conclude, then we have this compound that is more basic, this compound that is more basic, then this guanidine type of structure, this is more basic, third, then this compound, this is more basic, and this alkylamine, this is more basic. So we have 5 compounds that are more basic than aniline. Those are given over here. This is first, then this is second, third, fourth, and fifth. So the answer to this question is 5. 5 compounds are more basic than aniline. This is the required solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.